first presentation paper is Engineering neuronal growth cones to promote axon regeneration over inhibitory molecules on PNS at 2011. In this article, researchers aim to promote axon growth by directly targeting the growth cone, machinery that derives axon extension. They focus on non-muscle myosin 2, which powers retrograde actin flow in the growth cone. The pharmacological inhibition or genetic silencing of NM2 accelerates axon growth over permissive and non-permissive substrates by reorganization of both actin and microtubules. Then I will explain briefly their experiment results. First, researchers tested whether axon growth could be enhanced by inhibiting non-muscle myosin 2 activity. They applied blebistatin, which is specific inhibitor of non-muscle myosin 2 ATPase activity, and Y27632, the blockade of Rho kinase activity, and N-agrican, a member of chondroitin sulfate proteoglycans. By blebistatin, axon growth of neurons was enhanced in a dose-dependent manner on permissive substrates, and they overcame CSPG's induced axon growth inhibition. Next, they examined if inhibition of non-muscle myosin 2 could enhance axon growth from adult neurons, which should be more relevant to axon regeneration, and tested two major non-muscle myosin 2 isoforms, NM2A and NM2B. The results from adult neurons were almost similar to embryonic neurons results, and transfection with siRNAs against NM2A and/or NM2B suggests that blockade of NM2A activity is responsible for the axon growth promoting effect of blebistatin on permissive substrates, whereas on inhibitory substrates, axon growth promotion is attributed to inhibition of both NM2A and NM2B. Also, they examined the localization of NM2A and NM2B in the growth cone and growth cone cytoskeletal structures reorganization in response to blebistatin. From the data, they could recognize that NM2A appeared to be in transitional zone, which was similar to that of NM2B, and also be associated with actin filaments in the peripheral region. The localization change of NM2 isoforms and reorganization of microtubules in response to blebistatin provides a structural basis for the effect of blebistatin. Then researchers focused on the interplay between actin and microtubules. They measured the fluorescent intensity of F-actin in the growth cone and examined the effect to axon growth rate of cytoskeletal reorganization induced by non-muscle myosin 2 inhibition by performing time course experiments. These results showed both actin and microtubule dynamics are required for the axon growth promotion induced by blebistatin over inhibitory substrates, and it's perhaps the interplay between the two polymers that brings about rapid axon extension in response to blebistatin. Finally, researchers modified the two-compartment culture platform for mimicking efficient permissive inhibitory border environment. When axons encountered the permissive inhibitory border, axon growth into the axonal compartment was prevented, and axons formed retraction bulb-like swellings at the border, but blebistatin-treated axons enabled to exit the channels and grow into the inhibitory terrain. In summary, researchers reported on unprecedented marked acceleration of axon growth over multiple inhibitors by blockade of NM2 activity, and this phenomenon related with reorganization of actin and microtubules in the growth cone. This study provides an effective way to boost the intrinsic ability of axon assembly by direct regulation of growth cone motility and a possibility of inducing robust axon assembly over growth impediments without degrading the individual components that prevent axon growth.